Alrighty guys, so this is going to be going over the substitution rule, and which basically says if u equals g of x is a differentiable function whose range is an interval I and f is continuous on I, then the integral of f of g of x times g prime of x dx equals to the integral of f of u du. Now, I was a little confused initially looking at this because, it's just a bunch of, f of x, g of x, g prime of x. It's like, oh gosh. But when you break it up into an example problem, it becomes a lot more simple. But basically, there's two parts of this equation. You have the f of g of x, and you also have the, the g prime of x, okay? And basically, you use this substitution rule to make the integral super easy. So you go from complicated integral to simple integral. And then it becomes, an easy integral that's doable to solve. So honestly, the best way I can show this is with an example. So let's get to the example. Alright, so this is going to be our first example for the u-sub. Here I have the equation, or the integral, x squared times cosine of x cubed dx. Now, as we show up here, we'll use, the composite function, I guess we'll call it, as the purple pen, and we'll use the, the single function as the red pen. So in this case, we have cosine of x cubed. That is our composite function, because it's cosine, which is already a function, and then of another function, which is x cubed. Our single outlier is x squared. Now, based on this formula, it says that this is your f of x is cosine of x, okay? And your g of x is your x cubed. When you take the derivative of this inside function, it's supposed to give you your g prime of x. So the derivative of the inside equals equal to this, essentially. So, when you work it out, you essentially here should set u equal to x cubed. Okay? Because when you take the derivative of x cubed, you end up getting x squared. Well, x cubed, the derivative is 3x squared, but x squared is included in your answer. So in this case, I want to find the derivative of this. So I'm going to, find the derivative. Okay, dx. dx is important. So in this case, now you see that I have the x squared again, and an x squared is there. So we're trying to make this entire equation simple so it ends up looking like, from all this jumbled mess to this nice and simple, clean integral. So here we have the 3x squared dx. So if we wanted, this essentially is like your canceling area. This is where you're going to cancel it from the original equation. So dx can cancel with dx, and x squared can cancel with x squared. But as you notice, there's a 3 here. 3 is not included in this. It can't cancel, so you have to get it out of the way. You have to move it over. So, dividing by 3 on both sides, you get 1 over 3 du is equal to x squared, dx. Okay? Just like that. Now, you can essentially, you're canceling those. So, those are gone now. Okay? Now you're just left with that super simple function, cosine of x cubed, which is essentially just f of u. And our u is equal to x cubed. Okay? So, we reset up the integral. So we can reset it up as, we want to keep that 1 over 3 on the outside because it's a constant. There's no x's or y's or anything in there, so it's just a 1 over 3. It's a solid number. So we're going to keep it on the outside. So we're going to do 1 over 3 times the integral of, our x squared and our dx canceled because we got rid of them here. We're going to multiply, or set up the integral as cosine of u du. Because remember, our du is still, that's still a thing. We can't just get rid of it yet. Until the substitution is done. So this is our new integral. Now, as you can tell, when you go from this to this, it becomes a lot simpler, okay? So, and that just becomes a very simple integral, the integral of cosine is sine, so it's just sine of u, plus c. Because it is an indefinite integral, you have to add that constant at the end, or you will get the question wrong. And then once you finish the integral, you can plug your u back in to the u in your final answer. So in this case, it would be 1 over 3 times sine of, plugging it back in, x cubed plus c, okay? And that solves that U-sub problem.